Alright, so this is kind of new for me, but I've propped my camera up at a new angle so that when I sit in front of the computer, the camera is not directly in front of my face. So I'm kind of hoping that that's going to let me use the camera for a longer period of time without my hands getting, or my neck getting a crick in them. So it was suggested to me by a friend that because I'm doing native programming right on a Commodore 128, I don't think you can actually see the Commodore 128 in the camera right now, but this is a Commodore 128, that people in the world might think it was kind of cool to see how I do that. So I've got something that I need to do today. I've been working on the TKInput object-oriented text input class for C64 OS's toolkit, and I just got it working last night, but it's got some bugs. So this is my regular programming session. It is 20 minutes to 1 in the morning, and I'm gonna debug. So I've got Jiffy DOS installed. Slap the F1 button there to list a directory. So this is the source code for the toolkit, and so I got my source code files and the object files mixed in here. And so TKInput.r is the compiled file, and TKInput.a is the source code. So one of the things, here's what we're going to do. We're going to boot C64 OS so that I can get a feel for the weird buggy behavior. Alright, so test ground is where I've got my text field. Yeah, so here's the first problem. As far as I know, I am initializing the buffer to with a 0, but for some weird reason it gets one character in there. I'm not entirely sure what's going on there. And when we click in the field, yeah, it appears that it puts the cursor following that character. So it really seems as though there actually is one character in there, and that the null terminator is at like index 1 instead of index 0. So we can look into that. I've got my notes, keep my notes on stickies. So what do we got here? Actually, I don't have a note about that, so I'm going to make a note of that. What do we say here? That the initial string buffer has an A. Now here's the other thing that's a bit weird. So it actually has a reverse A. So typically when we type into this field, like I'll type my name, because the text I'm typing in is not reversed, but the characters that are appearing in the field are reversed. In order for this A to appear not reversed, it means that it is reversing a reversed character. So a lowercase a that is reversed. Again, I'm just using, if you want to know what I'm actually doing here, I have my complete interspace anthology, and I basically leave it open to a couple of pages in the middle. So, so I can look stuff up, right? So ASCII lowercase a is a 65. ASCII uppercase a is a 193, but this is a lowercase a. But it's reversed, right? So I'm not sure. I don't know where that's coming from. I can't tell whether that's because it's an 81. I don't know where that 81's coming from. Anyway, let's see if we can delete it. Okay, so we can delete it. Now, I think I have another bug. Let's put in some characters. Go to the beginning. I think if I delete to the left of the 0th character, yeah, okay. So that did something completely bizarro. Gotta have a note on that. Deleting with a 0 length string is completely effed up. Yeah, I don't know what's going on there. I think what's going on there. Okay, I think what's going on there. Okay, I got to think this through, right? I'm trying to think about what's going on. So the reason you don't see any crap here is because there are actually 0 bytes in here. So when it comes to rendering the string, it interprets the string as being finished because it's hit a 0 byte. And so then the field is empty beyond that. But when I deleted when the string was already empty and I hit delete, I believe what it did was it wrapped, I think this is my guess. I'm going to guess that it subtracted 1 from the string length. But the string length was already 0. So that probably rolled the string length over to FF. And now all of a sudden I have this FF long string. And because I have an FF long string, it's allowing me to cursor into the string this way. But these are, actually, yeah, I could probably use, okay, so these ats, they're what happens when you render a 0. And we note that it is reversed. So my guess is that that initial buffer must be holding a 1. Yeah, the initial buffer must be holding a 1. Okay, so we can think about, we can maybe make a note of that. Just as it's holding a 1. We can check our source code later on that one. Okay, and then, okay, so then I'm 99% sure that I'm underflowing the string. When the string length is 0 and I hit delete, it's underflowing the string length, rolling it back to FF, and that allows me to cursor into the string. And so from the beginning to here, it's just rendering the 0 bytes that are in the buffer. And then, but because it's a 0 byte where the cursor is, after that it's not. Now here's the other thing that I'm trying to figure out. Let's quit this. Let's just go home here. So this will, I just need to reinitialize because I don't know what's been screwed up by messing around with it. Okay, so we're back to our A. Okay, so let's get rid of the A. Now, you note here now that I can't cursor that way. So before I've done that too far delete left problem, I can't cursor that way. So I know that my string length is actually 0 right now. Okay, so let's put in some data. Gregory. Asia. That's my name. Oh, Christ. Okay, that's just a moth. I got a centipede problem down here in my basement. It drives me insane. Okay, so one of the things that's not working is, let me kill that moth. Moth is dead. Okay, one of the things that is not working, should be working, we're going to go check this in the source code too, is a couple things. Oh my god, that does work. That is the first time I've tested that. Oh man, that is cool. You are literally seeing live the first time I've ever tested that. Okay, so this is kind of a cool feature. I didn't even realize this was working, but I did implement it. So if you click on a character, so we'll click on a character. If you drag up, it'll make a selection from that character all the way to that end of the field. Okay, and if you click on a character and you drag down, it'll select all the way to that end of the field. Now let's see if range, you see that's some kind of bug there. Okay, let's see if range deletes are working. So I'm going to click on, come on, I'm going to click on here and I'm going to drag up. And now I'm going to overtype that with Frank. So we'll hit F. Oh my god, I can't believe that worked. Wow, that is hot. That is hot. I have no idea what's going on with that M. So that's some kind of bug there. And now let's say from N, we'll go down, we'll call him Frank Thomas. Okay, that didn't work. Okay, that didn't work. Thomas. Let's click here, down, hit delete. Yeah, that didn't work. But you know what did work was going that way. We'll rename that as Gregory Thomas. Something weird's going on there. Yeah, something's weird. Something weird's going on there. Okay. In any case, what it's not working is holding Shift. You can see it's not working at all. Holding Shift and moving the cursor back and forth. All right, let's get out of here. I've seen enough. I've seen enough to give myself some ideas about what bugs I should be looking for. Okay, so, alright, let's just try and fix a couple of the bugs that I already have. I already know. So I like to keep my paths nice and short because the Commodore file systems don't allow you to do a relative path. So I'm always typing in absolute. They don't allow you to do a relative path up and then back down. So you do a relative path forward, you can't go up and then back down in one command. So I usually just do absolute paths. So here's my toolkit source code. Now to open Turbo Macro Pro, again, I just put that tool in the root directory, so it's super easy to reference, like so. And we'll load in our back arrow L to load, so we're going to load in TKInput.a. Get a feel for about how long it takes to load. Not a huge wait, right? Okay, so let's, what's the first thing we're going to do? First thing we're going to do... No, you know what? I've completely, the first thing I'm going to check is whether that buffer has a 1 in it or not. So that is not actually done in the TKInput. It's actually done in OS Applications Test Ground source code. I can list a directory from within, so we can see we have main and init. So it's in init. So I can just load init over top. And I can use my F keys to move up and down the source code. So somewhere down in here I'm actually initializing. Here we are. So here's where I'm creating the input. I'm creating the input file, the input class rather. So we basically grab, so I've dynamically loaded the class, and I've stored the address of where the class is in memory to TKInput C. So I can grab a pointer to that and say TKnew, jump to TKnew. That'll initialize, that'll create a new TKInput object. Then I get the method init and jump to that. So that'll initialize the method. Set a couple of properties to anchor it. So we can offset it 12 from the top of its parent. Left 1, I just wanted it to sit in 1. Do some anchoring. Actually not sure if that's necessary. I think that might be the default. But that'll basically anchor it to its top, left, and right. So that's, when I resize that split, it resizes with the width of the split because I've anchored it. I've anchored its right edge and its left edge to its parent. Okay, so that's done with that. Next, what we do is we prep the setString method. So the input has a setString method. So you can have one input class, which basically edits a string, and then you can have a buffer of some size somewhere in memory. You have to create the buffer yourself. But you can have like a static buffer that's, say, let's say you want to do like an IP address. You want a static buffer that's, I don't know, whatever the maximum is, 3 times 4 plus 3. So 3 times 5, I guess. So you could make a buffer that's, say, you could statically make a buffer that's, say, 15 characters plus you need a terminator. So let's say 16. So you could statically allocate a 16 bytes in memory. Initialize the 0 byte. You can actually put some data in it first if you want to, or you could just stick a 0 byte in the 0th index of that buffer, and then you could call setString on the TK input and simply point it at your string. And you also have to say how big the buffer is, right? Because initially the string will be 0 terminated, so it only knows how long the string is, but it can't know how much memory you've allocated. So you point to the string, and then you also say, regardless of how long the string is right now, how long can the string be, plus 1 for the... No, I think you actually specify how long the string can be. But your buffer has to be 1 more than that to accommodate the terminator. So I prep that method, get str, and then I use some C64 OS memory management to allocate 1 page of memory, so 256 bytes. And that gives you back the page address. It's always page aligned. The allocated pages are always page aligned. So that gives you back the page in the Y register. And so we can set the X register to 0. And then we will write X and Y to PTR, which is a 0-page pointer I have to find somewhere else. So now I've got a pointer to the buffer that the 1-page buffer that I've just allocated. And now I want to say load Y, that's the index, with 0. Oh, look at that. That's the bug right there. That's the bug. Look at that. That is the bug. So so what I was trying to do was, I've already set Y to 0, but I want to write 0 into 0, right? So I want to write 0 a 0 byte into the 0th index. So I wanted to write, I wanted A to be 0, and then write A at 0. But because Y has already just been written with a 0, it's like you could save a byte of memory. If instead of loading A with 0, well, why not just transfer the 0 that's from Y into A? Except that I've done it exactly opposite, so there we go. It should be transfer Y to A. Okay, that will literally be that. So let us save that. Now let's just back up for a second. I can list my directory. Init.a is the file I'm working on. Init.o is the object. So we have to be extremely careful right here. We're going to hit the back arrow and then S to save. Now we're using a DOS command, at, and then colon. So the at is the command to overwrite the file. So I'm going to say init.a to save my source code. Actually, that's not the part that needs to be really precise. The part that needs to be really precise is now we're going to assemble that. So we're going to hit back 5 to assemble to an object file. Here's where you have to be very careful, because now I'm saving an object file, and you do not want to save your object file over top of your source code file. So I have to be super careful here that you don't misname the object file, because there are no questions asked. This is 8-bit land. Now this is also kind of the slow part, but you'll note I picked up my cup of coffee. Picked up my cup of coffee, and here is where I just kick back. For example, got an older copy of C64 that I'm working my way through. So I'm in the middle of this interview with Andrew Davey. So I read that sometimes when I'm waiting for things to assemble, or I update my notes. So for example, what did we just do? Oh yeah, so initial buffer was reverse 1. I could actually probably try and think about why exactly what was going on there. Actually, it's unpredictable what was going to happen, because I loaded Y with 0, but then I was accidentally overwriting Y with the contents of A. Oh yeah, actually it does make sense. So A, for its own reason, must have contained a 1. Yeah, A must have contained a 1. So what was going to happen, so what ended up happening is that A still contained a 1, but it got transferred into Y, so now Y contains a 1. So then what was happening was that I was writing to index 1, A1. Does that make any sense? No, that doesn't make any sense. That doesn't make any sense. Well, anyway, figuring out exactly what it was doing is sometimes fun, but not particularly necessary. Mostly I can just say, oh yeah, so here's a little thing that I do. Once I have dealt with a I put a little I put a dash for a bullet point for all my notes. But once I think that I've actually dealt with it, but I haven't tested to prove that I've dealt with it, I put a little square. See, I put a little box around the dash. So that just tells me if I go off and do other things. It just reminds me that, oh yeah, I've already dealt with that, but I haven't tested it. Once I've tested it, I'll actually scratch it. If it works, I'll scratch it. But otherwise, yeah, okay, so there we go. So what the hell, let's just really quickly boot up C64 OS. Excuse me, just to see if, just so we can kind of see around a complete cycle, around a complete round cycle here. Normally, I wouldn't boot all the way up and test this. I'm pretty sure that's gonna do the thing, but even if it hasn't fixed it, I'd notice later. Normally I'd go off and do a bunch of these things before I boot up, otherwise the development would be really slow. But there you go, yeah, it worked. So the A is gone. Okay. Okay, so let's get out of here. So that's cool. Let's scratch that off the list. So you just watched a something native development. You just watched some. You watched a bug get fixed in native dev. Okay. The next so many problems. You know what? I recall one of the problems, and I didn't really make a note of it, but I'm going to. I was happy to see that when I clicked and dragged up, the selection went to the beginning of the line. But not only did it go to the beginning of the line, but when I started to type, it successfully cleared everything. Okay. So you click, that sets the anchor point. Then you drag up, that sets the insertion point. And so now I just have to think this through. So the insertion point, whenever the insertion point and the anchor point are not the same index, there's a range selection between them. If the anchor point and the insertion point are the same, that's just an insertion point. Now, I've made notes about all this stuff on paper, over here, down there on paper, but just to work this out in my mind. But so the way it works is you when you click, that sets the insertion point and the anchor point at the same place. So you can just go click, and boom, that moves the insertion point. Moves the insertion point and the anchor point at the same place. But if you go click, and then you start to drag, wherever you drag to, you're dragging the insertion point while leaving the anchor point behind. So you're separating the insertion point from the anchor point. And that is what constitutes a selection. Now, as it happens, you could click and drag in that direction. You could drag right. And you will leave the anchor point and drag the insertion point to some higher index. Now, once you've, it matters because when you have a selection, and then you just go and you hit a cursor key, where does the cursor end up? Does it end up at the beginning or the end? Well, actually what happens is that if the anchor and the insertion point are not at the same place, and therefore you have a range selection between them, if you manually move the cursor, what it does is it collapses, this is what it's supposed to do, it collapses the difference between the 2 points. But the way that it does that is it sets the anchor point equal to the insertion point. So if you drag this way, and then you push cursor right just once, it will go zip, and it'll move the anchor point up to the insertion point, and then maybe move it one over. But the other way around, if you click and you drag this way, and then you click the insertion point, it collapses the anchor this way. You can't actually see that from just a selection, but internally there's a logic to it based on the direction in which you dragged. Okay, so when you click and you drag up and it selects to that side, what that does is it leaves the anchor point where you clicked, and you drag up and it moves the anchor point to 0. And then when I overtyped, that was working. But when I tried it the other way, so I click, that sets the anchor point, then I drag down, what it does is it sets the insertion point to the length of the string. That's the end. But then when I typed, it was not clearing. Okay, so that's the point, right? I need to make a note of this. So if anchor is less than index, range delete is not working. Range delete is not working. So the funny thing is you actually need some terminology. You need to kind of know how it works in order to even make a note for yourself, right? So the note is if the anchor is less than the index. You have a selection that the anchor's here, the index is here. And then I happen to know that when you push a key, it should do a range delete. That's not working. All right, so where are we here? Let us switch to our toolkit directory. Open the assembler. Clear the buffer. Okay. We'll load in our source code file. It's been 30 minutes. You have been watching me for 30 minutes. All right, let's tackle this first one. Deleting with a 0 length string is fucking up. All right. So here's our jump table. And a delete is a key press. So we can jump to our key press routine. So we can jump to a label with back I, and we'll do key press. So here's key press. So now we have this sort of range, right? So we jump to, this is a kernel call to retrieve the most recent key pressed from the key pressed buffer. And then we can check to see what it is. So it's not a cursor up, not a cursor down, it's not a cursor left, it's not a cursor right. Delete. Yeah, so let's see what'll happen if it is a delete. Okay, so if it's a delete, it'll do a range select. It'll do a delete range. Or if it's a regular key, it's going to come down in here. The very first thing that it will do is a delete range. Because if you right? I mean, if you have some things selected and you hit delete, fine, it'll do a delete range. But if you have some things selected and you hit a letter Y, the first thing it has to do is delete everything anyway. So the problem is in delete range, probably. So let us see what happens with delete. Because it seems to work when anchor is greater than index. So if here's my pseudocode as well, just to help me figure out what's going on. So if index, oh yeah, right. So if you don't have a range selection, you just have an insertion point. The way that that's represented is that the anchor and the insertion point are simply the same. Now, if what you want to do is delete one character to the left of where you are, then if anchor and index are identical, then you can leave anchor where it is, you can decrement index, and now you have a range selection of just one character. and then you can call range delete. But if index and anchor are not the same, well then just call range delete without manipulating them, and you're going to delete the range selection that is already specified. So let's see what happens here. So we load the anchor, and then we decrement y, which is the index is 1 less than anchor. So from our this object, we load the anchor, then we decrement y so that now we've got an index, and we compare it to the index, the insertion index. Now, if they are not equal, we're going to skip decrementing index. So if they are not equal, we're going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's no problem there. If they are equal, we need to decrement index. So we're going to go, y is already set for reading index, so we're going to load index, set our carry, subtract 1, store it back at index, and then fall through to jump to delete range. So there's no problem with that. Delete range itself, though, must have a problem. Okay. So here's delete range. Okay. So delete range is a bit complicated, but it's basically divided into two sections. Delete range has got the part where anchor is less than index. So this is the part for if index is less than anchor. That actually seems to work. So we load index, we compare it to anchor, and BCS, branch if carry is set, it's going to branch if index is equal to or greater than anchor, aka it's not less than. So let's just count these up. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, that's completely fucked up already. What did I do wrong? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, that's fucked, isn't it? What did I do wrong? Okay, my guess is that this has been injected and I wasn't paying attention here, so hold on. You might say, Gregory, my friend, why on the green earth are you not using a label? And I will tell you why I am not using a label. Because in native coding, with this Turbo Macro Pro, you have a very limited number of labels. So I can hit run stop to toggle this status bar, like this. So I am currently already using 146 labels. I can only use 255 labels. So I have to be very careful about where I'm using labels. I cannot simply use a label here, 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 and everywhere. Okay, I just can't do it. So in a case like this where, you know what, once this is working, it's goddamn gonna work forever. Like, it's going to work once I get it working. And so to kill a label on something like this is just not really worth it. Now, but occasionally, especially when I'm in the middle of actually developing it and this stuff is changing, sometimes I'll add some code in here and I'll forget, oh shit, there was a relative reference and I didn't update it, and you know, whatever. My guess is that I added this part in. So let's just count and skip this and see if that was about right. So the instruction itself always starts at 0. So we can go 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I happen to know that that's an absolute address. It's just above somewhere. So 10, 11, 12, 13, 14. So that 14 was supposed to get down to here, not including this. Now, why am I doing this? So, this is going to be the anchor. Y is going to be the anchor. So I'm going to load the anchor. Decrement Y. I'm trying to make anchor equal to index here, right? That's what I'm trying to do. So, Y is already for the anchor. So I load the anchor, then I decrement Y, which will basically put it at the index for index, the insertion index. Set the carry, subtract the index. So I'm subtracting the index from the anchor. That's how I'm getting the delta. And I'm going to store that result at delta. Now, index, Y is still for index, so I'm going to load the index, then I'm going to increment Y and stash it at, oh yeah, as because I added in the second line of pseudocode. So this is the second line of pseudocode. So after I've computed the delta, the index, so index is over here, and anchor is over here, and I need to compute the delta. So I take the anchor, and I subtract from it the index, I get the delta. But when I delete all those characters, I need to move the anchor so that the anchor is back to the same spot as index. So I added that line in. So what I do here is Y is already for index, so I grab Y for index, and then I increment Y, stash it at anchor. That's fucked up this count. So now it should be basically 14, 15, 16, 17, 18, 19. It should be 19. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So let us update that to 19, and you know what? That's probably going to fix the problem. But just for shits and giggles, let's see what's going on down here. So assuming index is so we only jump down here if index is greater than anchor. So in that case, we're going to do the opposite. Delta will be index minus anchor, and then index will get set to anchor because we're going to move index up to here. You know what? That doesn't make any sense. Although we've gone meta here. we're beyond fixing the one bug. Let me just think about this though. Index is, oh no, that's correct. That's correct. So index, so you have a string. Index is way out here. Anchor is way back here. We compute the delta. We're going to delete all that. But anchor is where the index is going to be because we're deleting all that, so that this index is going to move back to here. So we have to set the index back to where anchor is, the smaller of the two. So that's probably right. So we load in the index, then we ink to get our anchor, and we subtract, set the carry and subtract the anchor, and we stash it at the delta. So now Y is already equal to anchor. So we load the anchor, and we decrement Y so that it's in index, and we write the anchor into index. Yeah, that should be right. That should be right. Now what do we do here? Let's just think about this for a second. Okay, yeah. Now that we've computed the delta, we've put the index at the right spot where it should be after the delete. Now what we do is we take from our string length and we subtract the delta. And then we make a kernel call. So for kernel call, we have a string library in the kernel. that supports a string delete. And so we prep our stir pointer, which is necessary for the kernel call to operate on. So we prep our string pointer. Then we load the index into Y. So Y is the start of the string delete. And then delta is how many characters to delete from the index. So, and then we make our kernel call stir delete. That's all working. So let's just save this. So we're going to save this as TKInput.a. And I am 99% sure, 95% sure, that's going to fix that. But before we go and assemble things and go look at it, because that'll take too long, let's tackle this guy. Deleting with a zero length string is fucking up. So we'll go back to our key press routine. And we'll jump down to our delete. Okay. Yeah, well, obviously, I mean, you can see it. You can see it right away. If index is equal to anchor, index minus minus, and then call del range. So obviously, what we need to do is not that. We need to say, we need to say, okay, if index, okay, so if index and anchor are not the same, it's always okay to delete between them. But if index and anchor are not the same, it's only safe to delete if index is not 0. Okay? So basically, in this code where we're going to subtract 1, before we subtract 1, we simply check to see if it's 0. And if it's 0, get the hell out of here. Now here of course, we've just modified this code and we have a relative offset. So I've noticed it this time. Got to pay attention to that. It's very constrained though, right? It just goes from here to here. So we've just added 2 bytes, so we just need to add 2 bytes. And we can count that manually. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's going to fix that. Let's save this again. That's going to fix deleting. It was actually, this comment's not general enough. The problem was not merely deleting when the string was 0 length, although that was a problem. The problem was actually deleting when index was at, when the insertion point index was at string index 0, which would happen when the string is actually 0 length, but it'll also happen when the string has some characters, but the cursor is at 0. Okay, so that'll fix that. Now, the next thing's a little more complicated. So, I'm trying to support keyboard shortcuts, and they're not working. So keyboard shortcuts are not handled by key press. They're handled by completely different. So key press is for like non-modified keys. But do key equivalent. So key equivalent, it's kind of a macOS terminology, key equivalent. This handles a completely different kernel level buffer for key presses that were combined with modifiers. So if you hold, Commodore A, that should generate a key equivalent. Now, I happen to know that I have a utility that lists utilities, and in that utility is a TKList class. And I happen to know that that is already working, and that it has keyboard support, and that you can, actually the table does as well, TK table. So for example, in the file manager, you can hold shift and you can push cursor down, and it will select files, or you can hold shift and you can hold shift and cursor up, and so this shift, the right shift beside the cursor key, is used to reverse the direction of the cursor key, but the left shift is used not to, the left shift in C64 OS, only with the cursor keys, does not reverse the direction of the cursor keys, but can be used with the cursor keys to make range selections. And of course I want to use exactly that kind of range selection in my text field, because I want you to be able to hold shift on this side, and then use the cursor keys over here with this shift to make range selections that go left or right. Okay, so I happen to know that the input class, actually let's go to the table class. I happen to know that the table class already supports this and that it works. So let us jump to, okay, so here we are. I've loaded the table class because I know that the table class supports this. But I see in this jump table for the table class that it's a JSR, and the JSR is, this is not, basically table doesn't override its superclass's key equivalent method. So JSR do key equiv? Fine. That means that table uses its superclass. Well, what is its superclass? Well, we come up here and we see its superclass is TSList. So I'm going to load in TSList. Whoops. TSList. That should be TKList, sorry. TKList. So now we come down to its jump table. Sure enough, it's got to do key equiv. And you can see that this really is object-oriented code. I'm now in the class implementation for TKList, and I'm editing the method that gets used by the table. So there's only one implementation. Excuse me. Yeah. So let's see how this works. One, two, three, four. Set super plus 4. 0, 1, 2, 3, 4. Right. Key press or key equiv. I see. I see. Okay. So this is doing some shenanigans here where this is kind of cool. But so depending on which method is being called, key equiv or key press, the list actually loads a pointer to itself, so the method offset. So if it's key equiv, it loads y with the key equiv method offset and then branches down to here. If it's key press, it loads y with the key press method offset. And then this line here writes the method offset down into here. The reason is because the implementations are the same for this particular class. So then what do? Now we read the key press callback. Alright. 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 Gotcha. Now, if there is no key press callback, all it does is propagates this or this to the superclass. But if there is a callback, then we get into this stuff. And here's where I actually cared. So here we call a kernel routine read key print, but that's for key print. I don't understand what this is doing. Ah, gotcha. Okay, now I understand. So we load the key press callback from the object, from this, and if it's defined. If it's not defined, we just call it super and move on with our lives. If the callback is defined, it writes the callback into jump vector, which is used for method calling. And then we do this stuff to figure out what key was being held, and a little bit of extra work. And then we call sysjump, which basically calls the callback. And then, if we did not handle it, we jump back up to calling the superclass. But if we did handle it, it fucks around. Yeah, damn. You know, what's funny is this isn't really going to help me. Not going to help me. Not going to help me. Let's just return to our TKInput class and just see if I can spot the error. So basically, it's going to be in do keyequiv. I'm pretty sure this part works. I can see the problem already. Yeah, I see the problem already. The problem is that I'm a complete and total idiot, and I'm not actually calling the kernel call to get the keyequiv. Look at that. Look at that. So this do keyequiv gets called on your object when there is a key equivalent. Let me have some sip of this coffee. Okay, here's how this works. Do key equivalent is called on the relevant object when there is a key equivalent buffered. It does not actually pass the stuff anywhere. It's not like it's passing the object through memory. It's on the buffer, and there's a kernel call that you can call to get the latest thing on the buffer. And so the message that there's something waiting is really just a series of calls until something says, oh, I can handle key equivalents, sure. And so the thing that actually knows how to handle key equivalents needs to make the kernel call to grab the event and then process the event. So here I am checking to see whether the events, I mean, I've put notes in here, pseudocode notes, but I'm not actually calling read key command. Isn't that funny? So I can hit run stop just to figure out what line I'm on, 228. Just gonna pop down here to the bottom to make sure that I've actually... So this is the list of externs. It's the list of relocatable jump kernel offsets. So this class is relocatable, but not only is the class relocatable, but when it gets relocated and instantiated, when this class gets relocated, I guess, and initialized, it also relocates all of these calls. So these are local calls to this file, but they're going to get redirected into where the kernel calls actually are. So that's kind of cool. So I have it here. Read K command is going to call read K command in the input kernel module. So read K command, just jump back to line 228. There it is, read K command. So we just go JSR read K command. And yeah, that should work. I mean, unless there's bugs in the rest of this, but I have no possible way of knowing whether there are bugs in the rest of this without actually testing it. Yeah, and some of this I haven't done yet. I haven't done copying. I haven't done cutting. I haven't done pasting. You see what I do is I just write in my pseudocode. Paste has the most complicated pseudocode. But I just, like, for copy, I've got a little bit of pseudocode with kernel calls to the clipboard and cut a little bit of pseudocode. And then I go back later and I'll implement that. So that the clipboard stuff for this class is still to come. Yeah, that should work though. Let's save that. Now here's the thing. I've just made a number of changes, and I don't know whether that's going to break my relocation. So I am going to do the slow assemble. So I don't know whether E4 is an appropriate place to assemble it to now that I've made some changes. So normally I do a whole crap ton of development before I actually do this, but I'm in the debugging phase, but I have made some changes, and I could risk and say, maybe E4 is still a good place to save to, but if it's not, I just waste time. So I'm going to assemble it to 1000. Got to be real careful here as well that we don't overwrite our source code. So we'll go to TKInput.r for a relocatable class file. Yeah, so you've been watching me for 1 hour, if you're still watching. Well, you can have a sip of coffee. It's now 20 to 2, not 20 to 1. You can update our notes, right? All of these should be working now, in theory. So cursor, right, beyond, end of string. I don't even know what that's about. I think I've solved that one already, though. Cursor left, not tracking properly. I gotta be honest. I think I've already solved those. Shift left, shift right. Not registering. Yeah, well, that's probably fixed. So let's put a little box around that. Control A, not working. Yeah, well, that is probably working now. What else we got here? Yeah, implement shift click to make a selection. Yep, gonna have to do that. So that's like, you click somewhere in the string, but then you hold shift, left shift, and you simply click somewhere else. Click. It should, if you click somewhere and you're holding shift, it should leave the insertion index exactly where it is and simply move the anchor. So that's kind of neat. You can imagine how it would work if you imagine you had a long select box text field and you clicked once in the middle. Boom. So now you're your anchor and your index, insertion index, are right in the middle. Boom, you got a cursor. Now you hold shift and you click, say, on the right. Boink. It moves anchor, or would it move index? I think it would actually leave anchor where it was and move index. Boop, to there. So now you get the selection in here. But if you continue to hold shift and you click over here, it's going to not give a crap where index was. It's going to just move indexed over here. And so what will happen is it will unselect this part of the string and select that part of the string. Now, I don't know if that's correct behavior, but that's what it would do in my implementation. All right, so this is done assembling. It's 5 pages, starting at 1000. Here's how we do our relocation. We drop to basic, we run OS C64 tools relocator. Little tool asks for the binary file name, TKInput.r. Okay, it's got a clear memory. I've shown a video of this before. It's got to scan through the file. It's 5 pages. It's basic. It's slow, but you know what? Fuck it. I could have written it in assembly to make it faster, but yeah, basic is useful. I got to admit, it's old, it's slow, but you know what? It is a Commodore 64 would be absolutely impoverished if it did not have basic just ready to go, right, all the time, because it is so friggin' useful for everything. Okay, so it's reading through the drive, scanning the file, and putting bytes up in there. And then when it's done, it'll spit out these addresses. Well, actually, okay, so it's done. So it'll tell us the actual page size. It'll tell us the actual byte size, the page size. That's basically rounding up to the nearest page. There you go, E4. E4 is available. So I didn't technically have to go through that phase of assembly, technically. Now here's the crazy thing. When I assembled to here, it brings in a bunch of labels from includes, and that kind of pollutes the labels index internal to the thing. So I always reload back to my saved, my last saved state before I assembled. And that also brings E4 back, so I can just assemble it again. Ah, right. Very careful here. You do not want to overwrite your source code. You actually have one chance. You have one chance. If you put in the wrong file name there and you overwrite your source code with your object code, it's still in memory. It's technically, if you notice that you did that and your source code file is still in memory, you could just save it again. You could just save your source code again over top of the correct source code file name. But if you leave and you start frigging around and you maybe boot C64 OS or you load in some other thing, you start corrupting memory, and now your source code is truly gone and you want to kill yourself. But I've only done that like twice in the last 5 years. I have done it a couple times. I've done it more than twice, but I've only done it twice where I think I've only done it once where I really lost code. And then I did it once where it was like, holy shit, but I didn't really lose anything. And then I've done it, I've done stupid things where I've lost source code and I've gone, okay, no problem, I got to back up. And I can just go to my backup. I've done it a few times where I actually need to go to my backup and pull a couple of files. Sometimes that happens. Sometimes it's not even a mistake, but you need to go back to your backup. Like one time I was like, okay, this code is crap. I'm just gonna like rewrite it. And so I start moving things around and deleting things and rewriting things, and I realize, oh my god, I have no idea how this worked. And all of my source code has changed. So what I do then is I'm like, hey, no problem. I got a backup. So I go to my backup source code and I pull the old file out with a new name, and I open up the old source code file and I just look through it, figure out, oh yeah, right. That's how it worked. Right. So exciting times. This will be done in a second. Then we're going to boot up. We're going to test all of these little guys and see how our efforts fare. I'm pretty sure these are done too. I don't know what that's about. Cursor left, not tracking properly. Cursor left, not tracking. Tracking, by the way, is like if you've got more text in the field than the width of the field, and the cursor hits the edge of the field, it needs to track the cursor. So that is to say, like, it needs to scroll the content so that the input cursor is back in view, preferably somewhere in the middle. I haven't done that part yet, but all right, let's get out of here and let's boot up and see how it goes. Exciting. Very exciting. All right, moment of truth. Explosions and colors. When a Commodore 64 crashes, it's usually pretty brilliant. Okay, so far so good. So we can click on our field. Yep, so we fixed that one. We fixed that A the last time, right? Yep. So let's actually just start with this. There we go. Ah, isn't that amazing? Hitting delete when the string is 0 length is not fucking anything up. So we'll put in my name again. Is a cool dude. Okay. So we'll. Okay, so that's very cool. Hitting delete. Okay, so let's scratch that guy. Helps. Let's try Control A, just for fun. I'll be a goddamn monkey's uncle. Look at that, it worked. It selected all. Ah, look at that. Say, so Control A. Now we'll hit cursor left. Ah, look at that. Yeah, brought it all the way to the beginning. Oh man, I love that. Now we'll hit Control A. Oh shit. Yeah, that fucked up, didn't it? You know what? That didn't fuck up. That I actually hit Control A and then I hit A. That actually worked. That worked, but it was a bit kind of wonky. All right, let's just type that all in again. 99% sure that was not a bug. That was just my jittery fingers. Greg Ori is a programmer. Okay? All right, here's the real moment of truth. Let's hold shift and hit left. Oh my monkey's uncle. I am so excited. Okay, that's not working. Okay, so holding shift and then doing shift left, that ain't working. But holding shift and pushing left, that is working. Okay, whoa. Holding shift and pushing down, that's also working. Holding shift and pushing, yeah. There's something about that actually. So holding left shift and holding right shift, that's not working. Okay, let us record this newfound information. By the way, Control A is working, so let's scratch that. Control A is working! Oh my god, I'm excited. What did I just try? Oh yeah, so... Okay. Left, shift, plus, right, shift, not working. Okay, so we'll look at that in a second. Cursor right beyond end of string. Honestly, I don't know what that's about. Like, seriously, I'm pretty sure that's old. There's no problem doing that. That must have been that it wasn't stopping at the 0 byte. It was just continuing on. Cursor left not tracking. I'm 99% sure that's working fine. That's fine. Doesn't seem to be a problem with that. Just scratch that. What else we got here? If anchor is less than in... Oh, yeah, of course. Right. I remember now. So let's say we click and we drag down and we hit delete. There we go. That worked. Yeah, that worked. And now let's say we click here. We drag up. That worked. Man, this is fucking cool. Doesn't that just feel cool? Like, it's starting to feel modern, right? Like, it's starting to feel like you've got actual controls, like, you know, range selections and, like, quick things, tricks you can do. Like, this is shit that only, you know, I'm used to only having in Mac OS. I'm super excited. Yeah, so that's working. Found our bugs there. Alright, so... Okay, what's this? Left, shift, shift, right. Not working, not registering. Left, shift, right. Yeah, but those are working. Shift, left. Shift, right is truly not working. Hold on. Shift down is working. Shift up is not. That's because it requires the other shift key. Oh my god, this is so fucking cool. Alright, this is a test of all that this text field can do. And we'll come back here. And we'll say, yeah, you know what? I don't want this word field. I want it to say, here's what we're going to say. We're going to delete field. Whoops. We're going to delete field and say text compo. We'll just put it in an Esperanto word. So we'll hit K. Yeah. Okay. So that's actually not a bug. I was going to point that out. Let's just put in the word field again. Yeah. So here's the thing. In a modern operating system, you get an insertion indicator that is a thin vertical bar that rests very evidently between the letters. This is not possible on Commodore 64. You could do it with a sprite, but fuck that. I'm not doing it with a sprite. It's too hard. On the Amiga, however, at least Amiga like 1.3 or whatever, it does pretty much what this is doing. It simply highlights the letter, just like on the Commodore 64 on the ready prompt. You get a full block, whatever. So what that means is that basically the letter is going to go precisely where the cursor is. And everything that's under the cursor and to the right of the cursor gets shifted down. So if the cursor is on the D in field and you put in an exclamation point, which I'm going to do, it's going to put the exclamation point between the L and the D. Okay? Which is exactly what it did. So when you make, let's go all the way to the end of this field, you'll note that the cursor can actually appear one beyond the last character. So technically, that cursor is resting on the index where the 0 byte is. Now that actually makes sense because that's where the next character is going to go. It's going to follow that exclamation point. But even from like a programmatic standpoint, that's correct, because the cursor is actually on the 0 byte. But just the way it was when it was on the D, it moves the D right and puts the thing in its place. That's going to move the 0 byte right and put the thing in its place. Well, that's exactly what it's supposed to do, is move the 0 byte right. So there's no actual, you don't need to check and see if you're at the end and add the 0 byte. You don't have to do any of that. It just moves the 0 byte for you automatically. Just like this, right? Put in another. But you will note now also that when you have what is it supposed to look like when you only have a selection that's one character long? Well, on a Mac or Windows or whatever, it would look like this, right? Because it would be as though you had dragged a bar from before the C to like after the C, and now you have this one character selection. It's like, right, but we can't do that. So what is so that's just an insertion point. That's not a one character selection. So what does a one character selection look like? Well, a one character selection looks like 2 characters are selected. And you might think, well, fuck, that doesn't make any sense. It does, because the final character is simply not included in the selection. It's just where the insertion point is. So this is basically, the selection goes from the C to where? Well, to the start of the A, not the whole A. And so then when we hit delete on that, it should delete just the C, which it does. Now the weird thing about that, a little bit weird. Well, let's just do an example of. We'll hit Shift down. Okay, so that's selected all the way to the end, and it also includes this blank spot at the end. So is it really going to delete the blank spot at the end? No, it's not going to delete the blank spot at the end. So this is the exact same scenario, but we're at the end of the string. So it's not actually going to delete that last character at the end, because it's the 0 byte. All it's going to do is going to delete these 1, 2, 3, 4 characters. Smudging the screen. It's going to delete these 4 characters, and this one that is selected is just going to get pulled up to here, which is exactly what will happen, right? Yeah. Now, here's what's a little bit weird, is what happens if we do this? So I think the insertion point is here. No, I think the anchor point is here. The insertion point is there. Now, how do I know that? If I push cursor right, I believe it will put the cursor either here or here, but not here. So let's try that. Oh, for fuck's sake. That's not what I anticipated. Okay, let's think about that. Okay, so what that means is that with a selection like this, all the way to the beginning, it's going to delete THIS blank, and it's going to leave I. Let's try that. Yeah, so it did. Okay. I don't know, I can't tell whether that's the way it's supposed to be or not. But it's cool, right? Man, that is so friggin' cool. Like, God, it's almost modern, isn't it? You know that the Macintosh from 1992 or whatever, I just sold the Color Classic a couple of weeks ago. But when it was over there on the bench, I'd boot it up and just test it out just for fun. So Mac OS 7 point something, like 7.1 or whatever the hell was installed on it, from like 1992 or 3, could not do this. You could drag a selection, which I can't do yet, but I will be able to eventually. You could drag a selection, but you could not hold the Shift key to you could not hold the shift key to make a selection using the keyboard. So it's, my God, my Commodore 64 has a feature that, like, you know, a 1992 Macintosh with like 10 megs of RAM doesn't have. Like, that's pretty cool. Also, I don't know when this changed or if it changed in some version of Amiga OS, but in 1.3, when they released 1.3, it's like you could not make selections in text fields. Like, you go to your Amiga 1.3 or 1.2, 1.3 though, open, say, the info window. So, like, click a disk, open the info, and then click in, like, the tool type field. You cannot make selections. You can't drag selections. You can't, I mean, you just can't make selections. So, in my opinion, this is pretty advanced. You know what? It's getting late. We've been recording for just shy of 1 hour and a half. You've seen some bugs. My cat just arrived. You've seen what I do to record my bugs. You've seen me do some native coding, and I hope it was interesting. I'm going to leave her there. Alright, thank you very much for watching. Hope you enjoyed it. Till next time.